Hello, this video is going to take a look at volumes of prisms and cylinders. This is section 10.7 in your book. And actually finding the volume of a solid is usually easier than finding the surface area. So if you were struggling with surface area, I think you'll find this a little bit easier. So basically, the volume of a prism is equal to the area of the base times the height. So if you have a prism, which has, if you remember, a prism has a polygon on the bottom and then the sides go straight up, you find the area of the base of that solid and multiply by the height and you will have the volume. Now, when you have to be a little bit careful about this would be a solid that looks something like we have here in example 1. But before we get too far ahead of ourselves, let's go ahead and find the volume of this prism right here. So we have a rectangular prism. The base is a rectangle. The big B stands for the area of the base. So if we have a rectangle that's 4 by 2, that area would be 8. And then multiply that by the height of the box or the prism times 3. And the area of this solid would be 24. 4 times 2 is 8. 8 times 3 is 24 cubic units. Cubic units, sometimes written as a U with a little 3 up there for cubic. All right, now let's take a look at example 1, which I've written here. Here's example 1. Well, do the sides go straight up as this solid is sitting? No. See how it's sitting on the bottom here is like a rectangle? The sides don't go straight up. So you have to orient this solid so that the sides do go straight up. So if you could imagine turning this up, sitting it on the base of the triangle now is on the bottom, and then do you see how the sides go straight up? Looks kind of like a wedge of cheese, right? Now we can apply our volume formula. The volume of this solid, this triangular prism, is equal to big B, which is the area of the base. Well, the base is a right triangle, and we know that the area of a triangle is 1/2 little b h. And this is where it gets a little confusing. This big B stands for the area of the base of the object. This B stands for the length of the base of the triangle. So this big B is the same as this, right? Maybe I should just say big B, the area of the base. Since it's a triangle, 1/2 little b h. Here's little b, and here's h. So we're finding the area of the triangle. Well, we have 8 times 6, which is 48, and half of that is 24. I was looking at this because you can see it a little bit better. This is the same. Do you see how this is 6 and this is 8? So this big B is equal to 24, and I can't remember what the units are they given here. Centimeters? That would be square centimeters. And then we multiply that by the height. So we're going to multiply that by 13 centimeters. And I'm sure that they've done this in the book. So they have put them in separately. But 6 times 8, 48, half of that is 24 times 13, gives us 312. So this volume here, our volume, is equal to 24 times 13, which is 312. And notice that we're doing squared centimeters times centimeters. So altogether that's cubic centimeters, or cm with a little 3. Volumes are in cubic units. So moving on to a cylinder, if you notice a cylinder, the sides still go straight up, correct? But your base is a circle. So if we do the area of the base times the height, since the base is a circle, that just becomes pi r squared h, because the area of a circle is pi r squared. So now let's take a look at this swimming pool. And we want to find the volume of this swimming pool. So they give us the diameter, which is 18. Notice that for the area of the base, we need the radius. So if the diameter is 18, the radius is 9. So r goes in as a 9. So we have pi r squared h, r is 9, the height is 4. The order of operations here, you have to square your 9 first. 81 times 4 would give you 324. If we left it in terms of pi, we could leave it just like that. But usually for a problem like this, we're going to go ahead and multiply by 3.14. So we have a volume here. Let me grab the calculator. We have a volume of 324 times pi. And where's my pi key? I'll just do. So we have 1017.36. That would be cubic feet. Volume is 1017.36 cubic feet. Now this is kind of an interesting question. It says find the capacity in gallons. 1 cubic foot is equal to about 7.481 gallons. So we need to go ahead and do our conversion, which we did a couple of months ago. We want to multiply this by 1, our unit analysis, our unit number. What is our unit number? That 1 cubic foot is equal to this many gallons, or this many gallons equals this many cubic feet. And since we have cubic feet, we want to multiply this with the cubic feet on the bottom. So we're going to multiply our volume here by 481 gallons in 1 cubic foot. Okay, notice that the cubic feet cancel. So we are going to take this number that's still on our calculator, and we're going to multiply that by 7.481. And we would end up with 77,610 gallons. 7,610, maybe 11 if we rounded it off. Because it's 0.8, round that up to 11 gallons. Alrighty. Let's go ahead and turn the page, because example 3 is kind of a unique problem here. The solid is composed of a rectangular prism and then 2 half cylinders. Well, the beauty about having 2 half cylinders is you could squish those together and you'd have 1 cylinder, correct? So we're going to find the volume of this 1 cylinder and the volume of this rectangular solid. Then we're going to add those together. We're measuring this to the nearest cubic foot. All right, let's put these cylinders together. If the diameter is 2, then the radius would be 1. So we're taking this piece and we're gluing those together. So we know that the volume for the cylinders is going to be pi r squared h. R is equal to 1. So 1 squared is still just 1. And the height of that cylinder is, tells us over here, if you can see that, 1.5 feet. So the volume of the cylinders, I'm going to put a little C down there for cylinders. 1 squared is 1 times 1.5 is 1.5 pi cubic feet. And then now I want to find the volume of the prism. Well, anything that is a rectangular based prism, the rectangular base is length times width. That's our big B, times the height. It just turns out to be length times width times height. So let's go ahead and take a look at this. We have one dimension of 3, a dimension of 2, and a dimension of 1.5. So this is going to be 3 times 2 times 1.5. Twice 1.5 is 3. 3 times 3 is 9. So we have 9 cubic feet. And I think that it probably wants me to approximate this. It does. In your book here, you can leave it, if you want to leave it in terms of pi, you cannot add the 9 and the 1.5. You'd have to leave it just like this. If you wanted to approximate that and put it together, we'd have to do 1.5 times pi, 1.5 times 3.14, enter, and then add that on to the 9, and we would get about 13.71. Round it to the nearest cubic foot, that would be 14 cubic feet. So the volume of the total would be approximately 14 cubic feet. Okay, so there you have it. Volumes of prisms and cylinders. Basically, it's the area of the base times the height.